Alright, so this is attempt 2 at this video. We'll see how it goes. Hopefully it's better than my last one. As I presented, well, you don't care. So, if onward and forward. So this is your warm-up. I asked if this is a transformer and then it transforms into this, what has happened to it? And you should be noticing, well, here he's facing that way, and here he's facing that way. Here his feet are like this, and here his feet are like that. But otherwise, I mean, he's pretty much identical. It's just like a mirror image, right? And in fact, if we put a mirror right there, and we looked at the edge of the mirror, and the transformer's looking into the mirror, what he would see would look pretty much like this. And we would call this a reflection. Okay, so that's the official term for it. It's flipped, it's identical, it's the same size, it's the same shape. It's just reversed, reflection. Next one, well, this one, it's not reflected. He's facing the same direction. His feet are looking the same. The rockets are looking the same. But what's happening? Well, here he's leaning this way, and here he's leaning this way. And, well, if we actually looked at it, well, what's happening is he's kind of shifting over, right? And if we had a point right here, and it was like a clock, he'd go from here, and then he'd look at it over here, right? He just kind of rotated, which in fact is what this is called. It's rotation. All right, with this one, now some of you had sneaky sharp eyes and said, well, this one's a little bit bigger. Okay, ignore that. Wasn't supposed to be. So imagine that these are the same size. What has happened? It's a translation, right? He just moved. He used to be here, now he's here. Same size, we're pretending. Same shape, definitely. Oriented the same way. Everything is the same except for his location. So he just translated. All right. What happened with this one? Well, he's facing the same way, so it's not a reflection. Well, yeah, we can say that he's moved, but really what we're looking at is here, he's here, and now he's smaller. And we would say that the official word that we would use, you might say shrunk, he shrank, or if you look at it from here to here, you would say he grew bigger. He dilated. It was dilation. Okay? And here are the lessons, or here's the actual notes for today. The goal is to be able to transform plane figures. That means figures that are on the coordinate plane. So it's two-dimensional figures, whether they're polygons or triangles or whatever, using translation, rotation, reflection, and dilation. 4 events. Okay, translation. This is a transformation slides a figure along a straight line. And you'll notice that the transformed figure has the same size and shape. And also typically the same orientation if that's all you've done as a translation. So if I have this one here, I can slide it down, I can slide it up, and I can slide it to the right. And that's what I'm going to do. I'm going to slide it to the right, and there it is. Look at that. Some people compared it to a frog. So if I put an eyeball right here, there's my frog, right? There's his mouth, there's his eye. It's the same thing here, right? There's his mouth, there's his eye. He's identical in every way except he's over here instead of being over here. That is translation. I want you to notice the points. Look, this point used to be here. Now it's here. This point used to be here. Now it's there. Oops, now it's there. This point used to be here. Now it's there. And you think, yes, Miss Decker, I see that. But the reason I bring that up is because I want you to think about each point moved the same direction, the same distance. That's key. All right. Next one is reflection. This is a transformation that flips a figure across the line called the line of reflection. That's that mirror that I was referring to before, right? But what's interesting here is that each original point of the figure and the new point are the same distance. So we're not going the same distance over for each point. It changes. Instead, what happens, well, I'll get there in a second. And notice still we have the same size and shape, but it is going to change in one key way. So there's our line of reflection. And if I look at this point and I think, well, how far did it go to get there? It's got to go the same distance to get there. Same thing with this point. It only had to go this far, so it only has to go that far. And this point is somewhere in between. It has to go that far, so it's got to go the same distance this way. And now you want to think, well, let's see. Right now the frog is facing left. And if we mirror it, if we flip it and reflect it, now it's going to be facing to the right. But the mouth is still on the bottom and the eyes are still on top. There we go. So now this is reflected. Mouth is still here, eye is still here. Same distance. So this point is all the way over there because this distance is the same as this distance. There we go. That's reflected. Rotation. This turns a figure around a given point, called the center of rotation. Still the same size and shape, but now the orientation is going to change a little bit. So let's say there's my point of rotation, my center of rotation. And if I attached strings to these points, there we go. There's my strings, and you got to play along here a little bit. And I started turning these strings this way. What would happen? Well, they'd be there. And then they'd be there. And then they'd be there. And then they'd be there. And now think about it. This string used to be attached all the way up here, right? So that point is all the way over there now. This string used to be attached right there, so that point is all the way over there now. So the whole shape has gone over there. And then if I erase my imaginary strings, I see it looks like that. I like to compare it also to a clock. If these strings were instead like the hands of a clock, and it spins around and around and around, always going from that same center point, right? That is rotation. All right, last transformation that we're talking about is dilation. This does change the size, but not the shape. The shape has to stay the same of a geometric figure. The center of the figure is known as the center of dilation. So here's where a bunch of people messed up, and the transformer paper kind of messed you up a little bit. You had a figure here, and then you had a smaller figure over here, but that's not what dilation does, not on its own. The scale factor describes how much larger or smaller it gets. It can also grow bigger, okay? So let's say that that's the center of our figure. So then that would mean that this is the center of dilation. So if I take this figure and I make it bigger, then each of these points, boom, 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 go outward from that center point. And if instead I shrink it, there we go. All those points move inward towards the center. And so my shape then is not going to be over here. It's going to be about there. Okay? That's not quite perfect, but you get the idea. All right. So then this was the notes that we started in class that became homework. And the first thing I wanted you to do is think about, well, what happened from this shape to this shape? And we're going to call this one down here. This is triangle TBP. See, there's T, there's B, and there's P. So triangle TBP. And we have a different triangle, triangle T sup 1. That's not T to the power of 1. When you've got a small number up there, it's superordinate. So it's sup 1. So T sup 1, B sup 1, B sup 1. Let me say that again. Triangle T sup 1, B sup 1, P sup 1. And so that's here. Here we go. T sup 1, B sup 1, P sup 1. So what's happened from this figure to this figure? Did it dilate? Did it rotate? Did it translate? Or did it reflect? Yeah, it just translated. All it did was it used to be here, and now it's there. It just shifted, right? It's the same size. It's the same exact shape. It just whoop, went up. So let's see. So it went, all of these points just went straight up, right? Okay, so what would we say? Well, actually, first let's get our title here. What's the title of this page in the notes? What happened? What was the transformation? It was a translation, right? All right, and so if we describe it, well, what's been going on? Triangle TBP was translated but that's not enough. We want to say how much. So let's take a look. I said before that we went up from this point to that point. Oh, what did I just say? We went up, right? Okay, it was translated up. But I want to say even more. I want to know how much. Well, let's see. From here, from B, up to B sup 1, we went bloop, 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 bloop. Okay, the last bloop was sad. How many? It went up 4 what? 4 units. All right. And if we look at each point, the same thing happened, right? From P to P sub 1, it went up 1, 2, 3, 4. From T to T sub 1, it went up 1, 2, 3, 4. Went up 4 each time. Okay. There's still one more thing I want you to do on this paper, and the other papers like it. We've got all this space over here. What are we doing with it? Triangle TBP. I want to know the coordinates of each point. So, and if you don't have room here, write it up here. Actually I'm going to write it to the side. What's the coordinates of point T? T, okay, so I had to move to the left, so that's negative. 1, 2, here, let me draw that. 1, 2, 3, 4, 5. All right, so my X value is 5. And I had to go up or down. Oh, not at all. So my Y value is 0. There's T. How about point B? Let's see, where's point B? I had to go left 2. So that means my X is negative 2. Oh, look at that. I made a mistake. Should that be positive 5? No, that should be negative 5. Okay, so I had to go left 2, so that's a negative 2. Comma, what's my Y value? I had to go down, so that's a negative. I had to go down 1, 2, 3. So it is negative 2, comma, negative 3. And of course, tell me what the coordinate of P is. And then do the same for triangle T sub 1, sub B sub 1, P sub 1. So T sub 1, what are those coordinates? Well, if I look, let's see, I had to go left. 1, 2, 3, 4, 5. Oh, that didn't change. Okay. So negative 5, comma. Oh, but now I did have to go up or down. I had to go up 1, 2, 3, 4. Negative 5, comma, 4. And do the same for B sub 1 and P sub 1. Okay. Do the same as close as you can. You may not be able to tell me exactly how many units or by how much something was rotated or shrunk or what have you, but you can definitely tell me these coordinates. Okay. So tell what happened, add the coordinates, and try to describe it to the best of your ability. All right, thanks for watching. See you in class.